So in our previous example, when we rubbed the two bodies, then the body will we say the two body will get the charge of the different nature, though we cannot identify which is plus, which is minus. Now that is, charge cannot be created nor be destroyed. It's just only transferring from one another. Like suppose this is a pipe in this case. Okay, I'm making a very bad one, and this is a cloth, right? When we rubbed, when we rubbed them, when we rubbed them, then what happened? Rubbing means giving energy to it, right? Giving energy to it. Now, because during the rubbing, as the heat is produced, so what will happen that some of the electrons may transfer to it. If the two electrons have been transferred to it, that means it is having excess of two electrons, while this is having the deficient of two electrons. So this will become, as it is deficient of two electrons and this is excess of electrons, this is get negatively charged, this will get positively charged. Okay, so from here the total charge, though during this process the total charge is 0, so charge cannot be created nor be destroyed. So this property of the charge is known as conserved. Charge cannot be created nor be destroyed. Okay, then another property we have learned, that like charges repel, unlike charges attract each other. So you can see this one. Another than that, if two electrons get transferred to it, for example in this case, then what will be the total charge? 2e. Okay, minus what? Electrons excess. And what is the total charge to it? Plus 2e. That means if suppose if here is a body, okay, and this body, let's say it is having deficiency of electrons by n number. Let's say it is having deficiency of electrons by n number, then what would be the total charge of it? This will be Ne. Okay, so E is the basic unit of charge. Okay, and this E is equal to 1.6 into 10 to power minus 19 coulomb. Okay, 1.6 into 10 to power minus 19 coulomb. Excess of electrons negatively charged. What to say, deficiency of electrons positively charged. Okay, so this, I hope charge quantization is clear to you. So the a body, suppose 2 electrons is added, then what will be the total charge? This will be into 2. 3 electrons is added, into 3. So the charge will get added by the amount of 1.6 into 10 to power minus 19 coulomb. So this property is called charge quantization. So in your note I have completely talked about this. Please have a look properly. I hope you will understand it. This, okay. Then another thing, we can, this is the symbol of charge. Even we use small q also as a symbol of charged. Okay, then coulomb is the unit of charge, named after the Augustine D. Coulomb. Okay, so student, please go properly to your notes about the charge quantization. Okay, now another thing, and now one more thing I forgot to tell to you is that in that example, previous example, when the rod, charge rod, when the charge rod was charged, right? When they are charge rod was brought to that cotton. Okay, let's say this is the cotton, right? Now, why it get attracted? Why it get attracted? Now, to study this attraction, we have to study one term which is known as the induction or polarization. Okay, or the polarization. polarization. Now, see, the matter in its original state is neutral. Like in my example also, in my book example also, I had taken the example of the carbon, right? Carbon, the number of proton is equal to the number of electrons. So when we take the carbon as an example, as 6 number of protons and 6 number of electrons, so it is, as a whole, it is neutral, right? So this is, we call it neutral. Now, when a charged body, suppose a body is charged. Now, when a charged body is brought near to the uncharged body, like in this case, charged body is brought near to the uncharged body, then what will happen? The charge will affect this material. Now, this material is also made up of electrons and protons. Now, suppose this has got charged negatively, then what will happen? If it gets negatively, then the electrons which are present in the cotton will get repelled, right? Right? And the positive protons will get attracted, right? So what will happen basically, that when a neutral body is placed near the charged body, then what will happen is that the body as a whole, though neutral, but the distribution of the electrons and protons will get affected. Like in this case, I'll take this as it gets, say, negatively charged because of the rubbing, frictional electricity, and when this is brought near to the cotton, then the electrons present in the cottons will get repelled, right? So what happened? This side will become slightly positive while the other side will become slightly negative, and this positive, as it is nearer, though it may be the distance of some micron or some what to say, some nanometer, but still this side get pressed, so it get attracted. Gravity has no effect because it's very light, less effect, so it get attracted. So this process is known as induction, and this what is happen to this is polarization. Okay, so here at this time, in this brief topic, I am discussing about the charge. What are the charges, positive and negative? What are the properties of the charges? Frictional electricity and induction and polarization.